All right, guys, so we're going to do a little intro to rational functions, and we're going to start with a nice real-world situation and kind of get the idea of what's going on and what these functions do and why they do what they do. So this situation is about the finance committee of a nonprofit summer camp. They're trying to set the cost for a 5-day camp. Okay, so the fixed cost for the entire camp is $2,400 per day, and that's going to include things such as rent. We have salaries, we have insurance and equipment. Okay, so an outside food service company will provide meals at a cost of $3 per camper. We're actually going to hold off on that for a minute, but we'll use that later on. And the campers will eat 3 meals per day. Okay, so basically, as a nonprofit camp, the camp just wants to cover its costs and not make any profit. So they're going to try and just get the costs to be split up among the campers, just so that it covers the costs. There's no extra profit being made here. Okay, and they're trying to figure out what would the fee need to be per camper to make that work. Okay, so number one here, initially the committee decides to calculate camper fees based on the fixed cost again, without the meals. Okay, so we're not going to worry about the meals for right now. So if we think about the total fixed cost for the 5 days, okay, they're telling us it's $2,400 per day, and if we do that for 5 days, just doing 2,400 times 5, the total fixed cost of this thing is going to end up being $12,000. Okay, and again, that's not with meals. That's just covering the basics up here, and that's just the fixed costs. All right, so if we're trying to determine how much should we charge so that the campers will cover the cost, but again, we don't make any profit, it's going to depend on how many campers there are, right? Like, for example, let's just start filling this table out here. If we had, let's just say for the sake of example, if there was one camper, if there's only one camper there, they'd have to cover the whole $12,000. Okay, so the fee per camper would be $12,000, so that would be a pretty nice camp. If we had, let's say, 50 campers, right? Just making up some numbers here. Right? I'm making up a number of campers, and I'm going to see what the cost would be. So I would have to take the 12,000 to get the cost per camper. I would take the 12,000 and have to divide it by 50, right? So if we did that, 12,000 divided by 50, it's $240 per camper. So that would be a way for them to cover the full $12,000 kind of evenly. Now, if we had, let's say, 100 campers, okay, if there were 100 campers there, to get the cost per camper, again, we would have to take the full $12,000 divided by 100 campers, and that should end up being $120 each. Okay, so as the number of campers is increasing, we can see that the fee per camper is decreasing, okay, which should make sense, right? You have more people splitting the cost. What if there was, say, 200? Okay, I could take the $12,000 divided by 200, and that would be $60 per camper. Okay, if there was 300, 300 campers, I'll take the $12,000 divided by 300, that should be 40, I believe. Okay, if we had 500, I'm just making up some of these numbers here, right? 12,000 divided by 500 is $24, okay, per camper. And then, let's just do one more. Let's say we had, what if we had 12,000 campers somehow? 12,000 campers. If we had 12,000 campers, it would cost $1 per camper. Okay, so if we wanted to kind of look at what was going on, it's clear that the number of, as the number of campers increases, like if we were to make a graph of this, which is what we're going to start doing, okay, if we were to do that, if we were to make the number of campers be the x value, okay, so these values here, the x coordinate, and then the fee per camper would be the y coordinate. Okay, it's the fee per camper, right? So it's going to be how much are they charging per person. So as we can see, as we kind of take a look at these values here, we'll look at a more accurate graph in a minute here, but you can see as the x values increase, right, as you get more campers, the fee per camper decreases. So it's going to look like something like where it's kind of decreasing. If you think of like a linear function, it would have a negative slope kind of going like this. But what we're going to see is actually it's not linear. These types of functions are going to be more of like a curve. Okay, but they're still going to have like that decreasing pattern to it. Okay, so let's kind of get into it and see what it looks like and kind of investigate a little bit. Okay, so part C here, we kind of did the graph. We did a rough graph of it before, and we'll do a more accurate one. I'll pull Decimal's image in a second here. But part D, can we write an algebraic rule for the fee per camper as a function of the number of campers? Okay, so basically, sounds fancy, but all they really want to do is they're saying get an equation. Okay, so basically the fee per camper, so f of x, okay, f of x, okay, or you could just do y equals, but let's get fancy. F of x equals, now how are we getting that fee per camper? Remember, we were taking the 12,000 and dividing it by x. And again, x is the number of campers. So however many campers there were, we were just taking the 12,000 and dividing it by x. Okay, so the y value, or the f of x, is 12,000 over x. Okay, some of the features, again, as we talked about, again, it's going to kind of have this little curve shape to it. It's a decreasing function. Okay, that means that as x gets bigger, the y values are getting smaller. Okay, it's kind of like having a negative slope, like I said. It is curved, okay, and we're going to see that when we plot the points accurately. And you could just plot some points on some graph paper, which we'll look at in a second. But it's curved, okay? It's not linear. It doesn't have a constant slope to it like a linear function did that we spent a lot of time on. Okay, so based on our work so far, is there a minimum camper fee? Okay, would this thing basically get down to zero? And the answer is really no. I mean, as you have more and more campers, the fee per camper just keeps getting smaller and smaller. And I guess it could eventually get down to like 1 cent or whatever. And our money currency system doesn't have anything smaller than that. But technically, like the graph itself just keeps the y values keep decreasing and decreasing, and it would eventually end up just getting super close to zero as we go farther out. Now it's never going to quite equal zero, okay, and it's never going to flip to and be like negative. It'll never be less than zero. You know, but again, if you had millions and millions of campers, the cost would be like so close to zero that, you know, it would basically be zero. Okay, so that's going to be an important concept for these as well. So if we think about the let's think about number 6 real quick, the domain and the range, okay, of this function. So the domain, again, is going to ask which x values make sense, okay? So in our case, the x values, again, are the number of campers, right? X value. So for this specific example, it's the number of campers. Now, what values make sense for that? Okay, could we have, for example, a negative number of campers? Hope not, right? Could we have a fraction? No. But could it go up to as high as it wants to go? Technically, yeah, sure, right? I mean, it could be 1 million people in this camp or whatever. So when we graphed this thing, the x values that we are interested in, the graph ends up looking something like this, is basically, we couldn't have 0, right? X couldn't be 0. And what you'll notice there is when x is 0, which would be right here, this graph doesn't have a y value, okay? If you think about why that is, the equation, again, is 12,000 over x. Okay, if x is 0, you know, you think about 12,000 divided by 0, right? It should kind of jump out at you. We can't really divide something by 0. So for me, for this situation, the number of campers would need to be greater than 0. We can't have it negative. And technically, since it's about number of campers and stuff, it should be a whole number as well. Okay, now the graph itself goes through decimals and fractions. If you just threw 12,000 over x into decimals or graphing calculator, it's not going to just only hit whole number x values. But for this context, it is only whole numbers. Okay, and then the range, if we think about the range, again, that's when we were talking about what would be the minimum cost per camper and all that stuff. The range, it's always going to be above 0 as well, because again, this y value here will never quite get to 0. And technically, if you had like 1 camper, the cost could be really, really high. So the graph itself does go to infinity for a y value, but in the context of this situation, I think the highest it could be is 12,000, because if you had 1 camper, that's what the cost would be. All right, so let's get back into it. We didn't really account for the meals. Okay, when we did this, we were just taking the 12,000 divided by X, okay? But let's think about now, okay? Customers are going to be, or campers are going to eat 3 meals per day at a cost of $3 per camper per meal. Okay, so you're eating breakfast, lunch, and dinner. Each one's $3. Okay, and we're doing that for 5 days. Okay, so if we think about 3 meals each day for 5 days, okay, and each meal is $3. So on a given day, you're spending $9, right? Breakfast, lunch, dinner, they're each $3. So $9 a day for 5 days. The total cost per camper for meals is going to be $45, right? 3 meals a day, $3 each for 5 days. 3 times 3 times 5, 9 times 5. Okay, so let's take a look now. If we want to complete the table now to determine the fee per camper, okay, that will guarantee that the camp does not lose money. Now we're including meals as well. So it's the fixed cost plus the cost of meals. So let's do a couple of these together. We don't have to do the whole table. So if there are 25 campers, right? So the fixed cost is locked in what we did before. That's the 12,000 no matter what. Okay, plus it's $45 for the meals per camper, and we had 25 campers. Okay, so the total cost of that camp, we do 12,000 plus 45 times 25 is $13,125. So that's just the cost, right? That's the total cost to run the camp plus meals. Now to get that per camper, okay, to get this first number here, we're going to take that 13,125 and we will divide it by how many campers there are, right? If you want to find out how much it costs per person, you divide by how many people there are. So when I divide by 25, I'm getting a $525 fee per camper. Okay, let's do another one. If there were 50 campers, okay, the total cost would be, we have the 12,000 plus it's 45 for the meals, but we have 50 campers now. Okay, so 12,000 plus 45 times 50 gets me $14,250. So that's the total fixed cost plus the meals. Now when I divide that by 50, because there are 50 people there, that means they would each have to pay $285. Okay, let's do one more. 75 people. The cost would be the 12,000 fixed cost. That's always there. It's 45 for the meals times 75 people. That's getting me, if I do 12,000 plus 45 times 75, that gives me a total cost of $15,375. Now if I divide that by the 75 people to get an average cost per person, it's down to $205 each. Okay, so let's think about what's happening. Let's jump down to the bottom row here. If there were X campers, okay, the fixed cost would be the 12,000 plus $45 for the meals, and we have X number of campers, so that's how many people's meals we have to pay for. That's going to be the fixed cost plus meals. So to get that per camper, all you need to do is take that same exact expression, right, find out how much it costs each, you divide by how many people there are, which is X. Okay, so let's think about what's going on here. This right here, this is just a linear expression, right? That just has a y-intercept of 12,000 and a slope of 45. That's linear. Okay, that's nothing new. It's this average over here, okay, which makes it a rational function. And the thing about rational functions is they have a variable in the denominator. Okay, that's what makes it have that curved shape. And that's what makes it like approach, like the last one got real close to 0 but never crossed. Okay, so I want to take a look at what each of these graphs look like. I did a graph on Desmos for us. If we take a look here, here's two graphs. The black one is the first one. Okay, that's just the 12,000. That's the one with no meals. Meals are not even considered here, right? And if we take a look, that's the one. As this thing continues out, we said it's just going to get closer and closer to 0, right? If you have more and more people, The $12,000 is just going to get divided up by more and more people. Eventually, we'll just approach zero. Okay, but the new one, the pink one there, whatever, I wrote the parentheses in red there. Just if you're using a graphing calculator, you're going to want to put them in parentheses. But in Desmos, you don't need them because you can write the fraction to look appropriate. But what I'm hoping you guys notice about that one, notice that this thing is actually up higher here. And the reason why is because the cost per camper, right, the 12,000 is getting split up, but every camper is paying for their own meals, right? So if we kind of followed this along here at $45, right, it doesn't matter how many campers you have, they're going to have to pay for their own meals no matter what. So you could have 1 million campers, okay? The X value could get really, really big. The Y value of this graph right here is still going to be approaching 45. It's never going to get below that because each camper is going to have to pay for their own meals, the $45 no matter what. Okay, so it's not approaching zero, it's approaching 45. And that's going to be a key concept. What that's called, that line that it's approaching, it's called a horizontal asymptote. And that's one of the key new features of what these graphs have that we haven't seen before. Okay, one other thing that we're going to be seeing real soon, notice these graphs, both of them, kind of go up here, and they're never going to they're not going to exist. Remember we talked about the X value can't be zero, right? You can't divide something by zero. So these graphs are just getting closer and closer to the y-axis, which is where x equals 0, and that's actually going to be come to be called a vertical asymptote because the graph's going to just approach it but never quite reach there. Okay, for some practice problems, on page 420 here, just a hint, they kind of give you a situation. A new startup company is producing cell phone chargers. The fixed cost is $800 per day. Okay, and then the total daily cost to produce X chargers is given by this 4X plus 800. Okay, so that's just telling you how much it costs the company to produce X chargers. Okay, so when they want you to find C of 100, they want you to find the total cost to produce 100 chargers. So all you're going to do is plug in the 100 for X, and it's going to give you some value, and that's going to again be the total cost to produce 100 chargers. Okay, that's just like evaluating a linear function. This now, when you divide that answer by 100, you are now getting the cost per charger, okay, or the average cost, because you're dividing the total cost by 100, and it's going to tell you how much it costs on average to produce each charger. Okay, so that's the difference on those. You can kind of walk through the rest here, and then just kind of play around. You may need to use Desmos to make a graph, and or not. Okay, you can just use the equations. So the equation, again, they're giving you the C of X. That's the cost to produce X chargers. I'll help you guys out with number 14. The average cost per charger is just going to be the 4X plus 800 divided by X. Okay, because when you divide it by X, it turns it into an average cost per charger. And that's the equation you guys will use to evaluate all of these things at number 16. And then also, I think you'll use that for number 17. Okay, so go ahead and try those out. That's rational functions and a nice real life type situation that may use them.